Hello, my name is Rachel Zeitlin. I'm a master's student at Malloy University. This is my thesis presentation on heterogeneous and homogeneous grouping implications on mathematical problem solving. Before I begin this presentation, I would like to give a shout out to Dr. Smith-Sanchez for her support and constructive feedback during this experience. In this study, I explored grouping students strategically in math instruction, whether homogeneous, which is same ability, or heterogeneous, which is mixed ability. This can shape how students learn, collaborate, and think critically. This study explores how alternating between these grouping methods supports problem-solving skills and promotes inclusive, effective learning environments. Grounded in Vygotsky's social constructivist theory and differentiated instruction, the research highlights how peer interaction and targeted teaching can bridge skill gaps. Vygotsky's zone of proximal development supports collaboration as a tool for deeper understanding, while differentiated instruction emphasizes tailoring lessons to meet diverse student needs. In math education, it is important for students to have structured peer dialogue to gain new and diverse perspectives. There is limited research that is examining the differentiation of alternating between grouping styles. This study fills that gap, investigating how a mixed approach may optimize student learning across all ability levels, giving students new and diverse perspectives from peers. The research questions. My primary research question was, what does the effect of the implementation of alternating heterogeneous and homogeneous grouping methodologies have on fourth grade students' mathematical problem-solving proficiency over a 4-week intervention period, as assessed by a targeted 15% minimum increase in assessment scores relative to initial baseline data, with subgroup analysis for high, medium, and low performing cohorts. Additionally, this research and my current teaching assignment led me to propose sub-questions. The first one being about peer learning and interaction when they differ between heterogeneous and homogeneous groups for mathematical problem-solving skills, focusing on subgroups of high, medium, and low performing students. The second question. What role does the frequency of alternation play in improving students' problem-solving skills? And what is the impact of heterogeneous versus homogeneous grouping on academic achievement of students with lower mathematical abilities? The problem. Fourth grade classrooms, like many others, reflect a wide range of student abilities. High-performing students excel at reasoning, but may benefit from explaining concepts to peers, reinforcing their learning. Lower performing students often need more foundational support, while medium performing students require a mix of guidance and opportunities to lead. This diversity demonstrates the importance of exploring grouping strategies that can address varied needs effectively. Despite the acknowledged importance of ability grouping in mathematics, this often is overlooked in elementary classrooms. This impacts students' foundational skills as they need to be exposed to different perspectives and work with peers of varying ability levels. Addressing this gap can help elementary teachers adjust their instructional practices. My research rationale. There are several reasons why I became interested in the topic of alternating between heterogeneous and homogeneous grouping strategies. First, as a fourth grade teacher, I've observed that my students in my class vary greatly in their mathematical abilities. High-performing students often benefit from explaining their thinking to others, while lower-performing students gain confidence by working with peers who can model problem-solving approaches. Peer learning and interaction are crucial for mathematical problem solving, as they allow students to discuss, question, and refine their thinking through collaboration. I wanted to understand if alternating these strategies could enhance engagement and improve students' problem solving skills. The population. This study was conducted in a public elementary school in a suburban setting in my fourth grade classroom, with a total of 18 students, 10 females and 8 males, all approximately 9 to 10 years of age, with many different socioeconomic and cultural backgrounds. The class included English language learners and students who had individualized education plans, making this the perfect sample for the research and the setting of homogeneous and heterogeneous grouping. For the methodology, this study was done over the course of 4 weeks. Students participated in math problem-solving activities focusing on multi-step word problems in both homogeneous and heterogeneous groups. Students were placed in these groups based on an initial math assessment. Student performance was evaluated through a combination of formative and summative assessments. A pre-assessment was given at the beginning of the study to establish a baseline score for each student. During the intervention process, weekly quizzes were given as a formative assessment to monitor progress and measure student growth during the process. All assessment scores were recorded on a spreadsheet, demonstrating quantitative analysis of score changes over time. Additionally, qualitative data were collected through classroom observations and student surveys at the end of the 4-week intervention period. Observations focused on student engagement, collaboration, and problem-solving abilities among each group. Data was inputted into a color-coded spreadsheet. For the literature review, it was noted that existing research studies have highlighted the benefits of grouping students based on their abilities. These studies discussed how cooperative grouping promoted student achievement, social interaction, and grouping students based on their ability can provide targeted instruction and accelerate learning for high-performing students. The results. After the 4-week intervention period and through analysis of data, the study's primary question was answered. All students showed improvement from the pre-assessment at the beginning to the post-assessment given at the end of the intervention period. Overall, the data indicated that the impact of alternating grouping improved mathematical problem-solving skills. As a class, students performed better after working in alternating groups as they were able to work with peers at different ability levels throughout the intervention period. Peer learning has been shown to improve problem-solving skills by promoting active engagement and providing opportunities for students to develop critical thinking skills. The results and student scores can be found in the tables provided. There are many limitations to this study, even though students' skills improved. First, the short-term duration of the intervention limits the ability to capture the long-term effects of alternating grouping on students' academic growth. Although the results indicated positive changes in students' performance, these improvements may not go beyond the intervention period. Another limitation is the sample size and composition. Expanding the study to a larger and more diverse sample would help determine whether these results are successful across different educational contexts. Lastly, the study did not account for outside variables such as emotional and behavioral issues. Implications. The findings of this study offer significant implications for teaching practices, instructional design, and future research and education. The results suggest that alternating between heterogeneous and homogeneous grouping can be an effective method for enhancing students' mathematical problem-solving skills. Teachers should consider using both types of groupings to support diverse learners, allowing for targeted instruction through homogeneous groups, while peer learning can be fostered in heterogeneous groups. In conclusion, this study explored the impact of alternating between heterogeneous and homogeneous grouping strategies on fourth-grade students' mathematical problem-solving proficiency over a 4-week intervention period. The results showed that alternating between these grouping types had a positive impact on students' mathematical problem-solving skills on all performance levels. By incorporating these findings into classroom practices, educators can create more dynamic, engaging, and effective learning experience for students of all performance levels. Participating in this research allowed me to gain more knowledge on action research, and this transformed my approach to supporting my 4th-grade students on mathematical problem-solving skills by offering a structured framework for intervention and assessment. Frequent data collection informed instructional needs, while ongoing reflection and research fostered my professional development. Once again, I would like to thank Dr. Smith-Sanchez, the Malloy faculty, and my family for supporting me in my thesis journey. Thank you.